Hi guys, now we're looking at Cartesian plane. So that is our topic for today. Okay, so let's start by sketching it. So this is our Cartesian plane. We will just go through it thoroughly. Our Cartesian plane. Then, hey, this is bad. Okay, then we have our line like that. Okay, so we're looking at the Cartesian plane. Normally we call this is our y, this is our x. Let's say we have numbers like that, 1, 2, 3, 4. So you can say 1, 2, 3, 4. And you can look at this one, 1, 2, 3. So this would be 1, 2, 3. This is 1, 2, 3. So this is -1, -2, -3. Then you have 1, 2, 3, 4. So this would be -1, -2, -3, -4. Alright, so this is our Cartesian plane, and then we can look at this point here. Suppose we're looking at a quadrant. Normally we're saying that this is our first quadrant. This is our first quadrant. Or let's try to look at points here. Let's say we are looking at this point here. We're saying this is point P. Point P. Point P, we have 2 to 3. 2 to 3. So this would be our point P. Actually, it should be here. 2 to 3. Then you can look at point Q. Minus 2 to 3. Minus 2 to 3. Minus 2 to 3. So this point should be here. And you can say it's Q. It's -2 to 3. Okay. And then we can say, if you're looking at this point here, then you have a graph like that. So the straight line that goes like that, then you can have a 90 degrees here, and the same thing here. We can say we have our 90 degrees here. So that is our quadrant. So we can look at the coordinate. This is called coordinate. We're calling this coordinate. So they're always in the form of P is x and y. So we're looking at x and y. So you see here, this is P is 2 is 2 is to minus 2 is to 3. Our 2 is x and our 3 is y. So we write it in this format here. Let's first or quickly look at the quadrant, and then let's look at the quadrant, and now we're introducing the angles as well. So if we're looking at quadrant and we're looking at the angles, so normally we can say this is our 0 degrees, then this is 90 degrees, this is 180 degrees, this is 270 degrees. So you can see the difference between them is 90. So from here to here it's 90, from here to here is 90 degrees. You can clearly see from here it should be just like that. It's 90 degrees because this is the sign we have been using for 90 degrees, and this would be 90 degrees, and this would be 90 degrees, and that would be 90 degrees, right? Okay. Okay, let's try to remove it. So this is our 90 degrees, and we have 70, and then we can have 360 here. This can carry on. You can still add 90 degrees. In fact, you can have 450 degrees here, you can have 540 degrees here, and etc. So you can keep adding the 90 degrees and rotate it. Okay, but we're looking at the quadrant and we're still in trigonometry. So here we're saying that we're looking at sine, we're looking at sine, cos, and tan as well. So we're saying that the ratio, we're looking at the ratios in a Cartesian plane. Here you can see we're saying all of them, all sine, cos, tan, they are positive in this quadrant, and normally we're calling this as a first quadrant. You can look at a first quadrant, quadrant. So the spelling is, sorry, so the spelling is first quadrant, and we're calling this a second quadrant. This one would be second quadrant. So here we can say sine is positive. This is our sine, and here we have a dead one, a dead quadrant, and then on our dead quadrant we're saying that tan is positive, and then here we have our fourth quadrant, and then we're saying that the cos is positive here. So later on we will get to it, just to understand what is it when we keep saying that it's negative or it's positive. Soon you will understand, but we just learned that this is our quadrant. We have first quadrant, we have a second quadrant, we have a third quadrant, and we have a fourth quadrant, and then just learn that this is 0, and then this is 90, this is 180, this is about 27. So if we're looking at angle from here to here, it's a 90 degrees. This angle is 90 degrees, and from there to there, this is 180 degrees, and then this is 270 degrees, and then this is 360 degrees. So the cycle of it is making, it makes a 360 degrees. So the cycle makes a 360 degrees, but a half of it, it's making 180. So if it's a straight line like this, it's half. So this angle here from here to here would be 180, and this angle here from here would be 180. So this is how we look at our Cartesian plane. Let's quickly look at some few examples. Okay, let's look at our examples here, and just to get an understanding of what we're talking about. Okay, so suppose we have something like that, and then we have our line here. Hey, this is very bad, sorry. So let's say, suppose we have our line here, and this is our right angle triangle, and we have point P, and our point P maybe is -3 is to 4. Okay, and then we're saying this is point P, -3 is to 4, and then we have an angle like that. We're saying this is an angle, and hence we're looking for this whole angle from here to here. Maybe we name it theta. So theta is the whole angle from here to here. So it's our theta, that one. So let's say the question says find angle theta. So this will be our x, and this will be our y. Suppose we want to find angle theta. So what can we do from here? If you look at it clearly, you can see this is our dotted line. So this is our x-axis, of which is -3, and then this is our y-axis, of which is 4. Okay, so we want to find angle theta. We can say this is 90 degrees, and then it could be the same way, where you can look at it and say you're looking at this angle. But let's try to work with this one here, and you see, to say from this is 4 unit. If you're looking at this side here, because it's on the y-axis, from here to here, it's 4 units because we have 4. But from here to here is 3 units, so this can be just 3. So this is 3 units, and then this is 4 units. So you see, if let's say we're trying to find this angle here, let's say we're trying to find this angle here, and that angle we can call it K. For example, let's say we want to find angle K. You see what we have, if we want to find angle K, we can say from this point of angle K, we have an opposite all over adjacent. So that is tan. Either way, we can still find what is this length here. This length here. So how can we find this length here? We can apply the Pythagoras theorem because we have a 90 degrees here. So suppose that we normally use this formula, r squared is equal to x squared plus y squared. And clearly you can see we name this side r. Let's say this side is r. So we know what is our x. Our x is -3. So we have -3 squared plus our y is 4 squared. So you can put that one in the calculator. So basically we have 9 plus 16. So that is 25. If you put this in the calculator, it's 25. So this is 25 is equal to r squared. You put a square root both sides. You put a square root there. You're left with r is equal to 5. So our r is 5. This length here is 5 units. Okay. But we are interested in finding k because we want to find theta. So how can we find k? And then we can, now because we know this side here, we can use sine, we can use any ratio, we can use sine, we can use cos, we can use tan, because if you're going to use tan, or if you're going to use tan, you can say it's an opposite all over adjacent. But because now we have our hypotenuse here, we can just say let's look at sine. Sine k is equal to 4 over 5, and then we can say our k is nothing but the inverse of sine into 4 over 5. Inverse of sine into 4 over 5. So we say shift sine is 4 over 5. So this will be nothing but k is equal to 53.13 degrees. So that is our k, of which is this angle here. This is this angle here. So let's say you didn't went all the way to find the hypotenuse, and because that was not necessary, you could still just look at k, and then you're looking at the opposite all over adjacent, which is tan. Let's try to see if that could work, because if you're looking at tan k, then if you didn't have to find the hypotenuse or to use the Pythagorean theorem, you could just say tan k is equal to 4 over 3, and this is nothing but k is equal to tan minus, that is an inverse 4 over 3. Let's see what we get from there. So let's look at shift tan 4 over 3. You will see we're getting the same thing. So k will be the same thing. K will be the same thing. So you can use anything that is given. So this is 1.2. You can use anything that is given. You can either decide to use tan, or you can either decide to find this side here, but it wasn't necessary because you've got two sides and you can find what is k. So let's get back to our questions, because we're trying to analyze it more, or to see if we can use different ways to find the solution. But the question is find theta, but what we got here now is k, but we are looking for theta. But what I told you earlier is that this whole angle, if you're looking at this angle here, from here to here, this angle is 180. So the half of a circle, is 180. This is equal to 180 degrees. But we got a small portion here of which is k. We got a small portion of which is k. So if we subtract this k, we should find this angle here, of which is what we're looking for, right? So what can we do? We can just say 180 degrees minus k. So this is nothing but equal to 180 degrees minus 53.13 degrees. So let's see what would be the answer. Minus 180. So the answer will be, the answer will be 126.87 degrees. So that is our theta, of which is this angle from here all the way to here is 126.87 degrees. Let's try to do another example on this one as well. Okay, now suppose we have this. Okay, and then we have our x, we have our y, so this goes to infinity. So this sign that I'm writing now here is just show that it's continuously, or it goes to infinity. So from this side it's to negative infinity to positive infinity. Okay, okay, let's look at this example here. Then we're given a coordinate. We are given a coordinate of which is k is 2 minus 5 is to y. Then they told us that the distance here is 13 units, right? Then they're saying that they're looking for this angle from here all the way to here. So they're looking for it, and then they're saying this is theta. So this is our angle theta from here all the way to here. We're looking for our theta, or angle theta. Okay, and then what we can do here, we have a coordinate. Let's look at this one, this coordinate. So we can just draw dotted line from here to here. Then we say this is our 90 degrees because it's a straight line, a vertical and the horizontal line meeting at this point, so it makes a 90 degrees, right? So to have a minus 5, it means this is 5 units. So it means we have 5 units. So what we can do, let's cut it shortly. Let's say this is beta. This angle is beta. This is our beta, angle beta. So if we're looking at angle beta, maybe I shouldn't write it like that. Okay, if you're looking at angle beta, let's say this is our beta, right? Much better. So we're looking at angle beta. We need to find beta. What can you do to find beta? You see, we're looking at this angle here, and then we don't know what is an opposite. We don't know the side because the side is y, which is something that is not given. But we do have an adjacent and then hypotenuse. So we can use cos. So we can say cos beta. We can just say cos beta is nothing but equal to, cos beta is equal to 5 over 13. This is cos. So this is beta equal to inverse of cos into 5 over 13. Then we're looking at our answer. So this will be shift cos 5 divided by 13. So this will be shift cos 5 divided by 13. Okay, so we got our answer. So we got our answer to be 67.38 degrees. So that is our beta. So we know what is this angle here. Suppose, because the required answer, we need to find what is our theta. So we got beta, and then we need to find what is our theta. So what do we know is that this angle here, from here to here, is 67, but we know already that from here to here is 180. So we already know that this angle here is 180 degrees. But what happened, we adding beta. So 180 plus beta, 180 plus beta is equal to theta, because we'll be adding from here all the way to here to get the total angle, right? So we know now what is our beta, so we can easily say that therefore 180 degrees plus 67.38 degrees should give us theta. So let's put it in the calculator. So plus 180 plus 180. So now we getting 247.38 is equal to theta. So that is equal to the whole angle from here all the way to here. It is equal to 247.38 degrees, right? Okay. In case we can still look at finding what is y actually, if you are still interested in that. So what is y? We can use Pythagoras theorem to find out what is y. Pythagoras theorem says r squared is equal to y squared plus x squared, and then our r squared, so in this case we have 13 squared is equal to y squared plus into minus 5 squared. So we can do that, therefore we have 13 squared minus into minus 5 squared is equal to y squared, because we're taking this term to the other side, that's why it's become negative here. So we can just put that in the calculator. Let's see, if we're saying 13 squared minus into minus 5 squared, that gives us 144. So this is 144 is equal to y squared. So we can put the square root both sides, so you can just square this one and square this one. So we're saying that square the answer, so you're getting 12. So 12 is equal to y. So from here to here is equal to 12. So this should be, if you're looking at here, this should be minus 12. And then we should have our k actually as minus 5 is to minus 12. Okay, so that is the case. Okay, thank you so much for watching. I hope this makes some difference or help somehow. Thank you.